Welcome to EDU World Space.
So these are Q1, Q2, Q3 and Q4 are four equal charges, and let us suppose that to be Q, and that is given as 8 into 10 to the power minus 6 coulombs, and the length of the square is given as L is equal to 9.2 centimeters. So, what charge should be placed at the center? Now, since all the four charges are positive, to bind them, we need a negative charge at the center. So, let us consider that to be minus q. Now, let us consider the force on one of the corners of the square. If due to the symmetry of the system, if one of the charges is stable, all the charges will be stable. So, let us first find, let us pick one charge here Q4 and find out the forces on that due to all other charges. So let's begin with force due to first charge on 4. So F41 is equal to K times Q squared, because both have charge Q, upon the distance is from F41 to 4 to 1 is L, so distance is L squared, right? Now F41 has all the components along X, so this is equal to F41 along X, and the force along Y component is 0. Alright, similarly, there is another force due to 2 charge 2, and that is located at a distance root under 12. So this should be K times Q square by twice L squared, right? So this gives me, this has two equal components on X and Y. So F4 to X is equal to KQ squared by twice L squared cos 45, right? So this is equal to K root 2 Q squared by 4L squared, and the same is along y-axis because that line passes exactly through the bisector of the angle. Similarly, F4 due to the third charge is equal to K Q squared by L squared, and this is all along the y-axis, right? So 4 3 y, and there is no force along x-axis, so F43x equals to 0 along x. So let me rub this. Okay, this is equal to 0, right? Similarly, on fourth charge due to q would be, since q is negative, so minus 2k q q upon L squared, which means that F4qx is equal to minus 2kq, same as F42, has two equal components, so for cos 45, which is equal to minus k root 2 q q upon L squared, and the same is along y-axis as well. Okay, now as for the charge to be stable, we can either equate the y component to 0 or all the x component be 0. So F net along x should be, of course, 0, right? So this implies, let us add the x components. So the first one is kq square by L squared. Now the second one is k q squared by L squared root 2 by 4. The third one is 0. The fourth one is minus k, let me write q squared by L squared 2q upon q. Right, sorry, root 2 q upon q. To take this kq square L square outside, so I just did this. So from here, if you take this kq square by L square common, so 1 plus root 2 by 4 minus root 2 q by q equals to 0. Now if you plug in the value of capital Q as 8 into 10 to the power minus 6, gives me the small q that is equal to 7.65 into 10 to the power minus 6 coulomb. So we should plug in a minus of q. So this is equal to minus of 7.65 into 10 to the power minus 6 coulombs. So this is a charge that should be kept at the center. So this is the solution to this problem.